Uh, Good morning, class. Today we are going to deal with this shear force and you can say bending moment diagram. Right. So it's a shear force and bending moment diagram of overhanging beam. Right. So first of all, let me start with this overhanging beam. Right. So how we can start with the shear force and bending moment diagram? So first of all, let's begin with this overhanging beam type. So it can be overhang at its on the one end. In just reverse order, you can say the one free end is on the left hand side, and you can also have this overhang beam like this, which has a hanging beam at both the side, RHS above the side. So it can be in three type of cases: first, second, and third. So it is very simple to solve this type of beam as once you have a beam like this, suppose this one is the overhang beam and which one is subjected to point load here at a mid span and UDL as a head span, alright. So I can say just it's a 2 meter, it's a 3 meter and again it's a 2 meter. The point load having a magnitude of 20 kilonewton and the UDL have magnitude of 5 kilonewton per meter. So here we can just give the name. It's a, it's a B, and this free end is a C, and this point load is a name as a D. Alright. So here we have this type of beam. So first of all, our job is step number one. Always is a calculation of support reaction. Uh, so how can we calculate the support reaction? So here we know that at a free end or either it's a simply support at its end, alright. So this support we can say it's a simple support at A, right? Which one is at the end, alright. So either at A or either at C. In this case, at the support B, moment will be not zero because it's an intermediate support, alright. And if your support is if your beam is simply supported but the support is intermediate, then there will be no you can't consider this moment at this particular support as a zero, alright. If a simple support is located at its end, right, then and then only moment is equal to zero. So you can consider that moment at A or here moment at C is equal to zero because C is a free end, right? And the free end moment is always zero. So you can say that. So let's begin with the C or either A. So let me start with this moment at A. So first of all, moment at A, which we know is equal to zero. So from the right hand side, first moment due to this point load, alright, you can say this is a point load and it's in a clockwise direction, so 20 into 2, alright, minus the support reaction is a VB, and VB is at a distance of 5 meter because it will apply anti-clockwise moment, alright, in anti-clockwise rotation. And UDL, if you simplify this UDL, so if you can focus on the simplified UDL, so overall span is a 2 meter because it's applied between the point B to point C. So 5 into 2 it's a 10 and it will always apply at the mid span. So it is at the distance of 1 meter and 1 meter from point B as well as from point C. And the magnitude is a 5 into 2 it's a 10 kilonewton if you find out the simplified form of this UDL. So here in this case the moment due to the UDL at point A, which one is a 1 plus 5. So it is a plus because it's a clockwise direction, so we can say it's a plus. Let me do this symbol here. So uh, that you will not get confused here. So it's a plus and it's a 10 into over 1 6. So you can say it's a 20 into 4 plus 10 into 6, it's almost 100, and you can take this term on the another side. So 100 is equal to, you can say VB into 5. So here you can probably say this VB is equal to 100 over 5, it's a 20 kilonewton. It's a support reaction at a point B. And as we know that summation of vertical force is equal to 0, so you can say VA plus VB is equal to turn downward force means 10 plus it's a 20, alright, so it's a 30. So VB is equal to 20. So you can say VA is equal to 10 kilonewton. So here you have a support reaction. I don't think so. It is very difficult job to draw this shear force diagram of this given problem. So let's begin with this shear force diagram of this given problem, and then after we can find it bending moment as well. Okay. So here in this case, shear force diagram that we have to draw. So first draw this entire beam. So entire beam has several points. This is the point A, and this is the point D. This is the point B, and you can see this is point C. So at point A, the support reaction is a 10 kilonewton. So I have to go up 10. All right. So it's a 10 kilonewton. I can just take this assumption of the scale. One line space is equal to 5, then it's two line is a 10. Okay, so from A to D there is no load, so you have to travel straight, and at the D this point load is acting with a magnitude of 20 kilonewton. So you can say once again it's a height of 10 kilonewton, and once again you have a same height as a both are 10 kilonewton. So the total scale is a 20 kilonewton. Then again up to B point there is no any load. Okay, it's fine. And from point B, the in actually in the downward direction, but actually at a point B, the support reaction acting in a opposite direction, the upper side, and support B reaction is at 20. So once again you have to go uh, 20 up. So you have to travel almost 10 kilonewton upside above the reference line. So the total scale will be 20 if you can take a scale of the shear force diagram. And as you know, this is the total UDL, 5 kilonewton per meter, and you can say it's acting on the 2 meter span. So total load is a 5 into 2, it's a 10 kilonewton, and 10 kilonewton you have to travel from point B to point C gradually downside. So your shear force diagram is look like this: positive, negative, and positive. So this one is your shear force diagram. Right. And right now your job is to draw the bending moment diagram of a given problem. So to draw the bending moment diagram, first let me help you to draw this line beam first. Then after we are going to calculate it, and after calculation we can say it's a shear force diagram, and it will be a bending moment diagram. So we have this space to calculate bending moment. Right. Okay. So first of all, let me erase this line first, but I'm going to make a boundary here as we have to draw the diagram. So at which point we have to find out the bending moment first, alright? So here at the 2 points, shear force will get a 0. So at a point B as well as at a point D, alright? Yeah, so we can find out the moment at point C, moment is 0. So we are going to find out moment at point D as well as at point B, right? So let me try to find out moment at D as well as moment at point B. So first of all, let's find out the moment at D. So here, as for the figure, which can be easier, LHS or RHS. So of course, if I make this section from the left hand side only, so it will be very easy to calculate it. So let's draw this diagram for the LHS portion only. So in LHS, I have to draw this only. One reaction, the reaction has a 10 kilonewton, and at the distance of 2 meters, there is a point D. So LHS moment, which one is the LHS anti-clockwise? So it's a minus 10 into 2. So you can say from the LHS you will get a moment minus 20 kilonewton meter, and definitely it's a anti-clockwise. And from the RHS it's a clockwise. Okay, from the LHS it is anti-clockwise, and of course it's my mistake. Let me clear it. Mm, sorry, from the LHS, the moment is applied on this portion, it is a positive, right? It's a clockwise, it's not an anti-clockwise. So here you can draw this rotation, right? So it's a clockwise, so it's a 10 into clockwise, 20 kilometer clockwise. So you can say this moment is a clockwise LHS, so definitely RHS in the opposite sign you will get anti-clockwise, so overall is a sagging. So you will get a sagging moment at here at point D, right? And in addition, if I want to find out this point moment at point D, rather than I am going to find out the moment at point B, right? So moment at point B, so it is easy to calculate the RHS only, right? Here as a point, this is a B, right? On the RHS, you can say it is a 5 kilonewton per meter magnitude. UDL is acting over a span 2 meter, right? So the total moment is look like this previous case is a 10 into 1, right? From the RHS. So 10 into 1, it's a clockwise. So RHS you will get a clockwise. It's just a 10 into 1, and the 10 into 1 you can get a moment as a 10 kilonewton into meter. But this moment is a RHS, and it's a RHS is a clockwise. So LHS you will get a anti-clockwise, and here the moment you can say finally it's a hogging, right? So it's a case of a hogging moment, and here it is a case of sagging moment. So at point D the moment is sagging 20 kilonewton. So in scale, if you want to present it, then it will be here, and here in a B point, if you want to scale it in a if you want to point it in a scale, so I can write here it's a 20 kilometer at the sagging, and at a B point it's a 10 kilometer, it's a hogging, so it's a above side, all right? So in this case, first of all, due to the point load application on the left hand side, so you have to draw this diagram as a straight line, all right? So yes, it's a straight line, and here is a moment, and then after up to point B there is no any application, only no load is acting over there rather than point load. So you have to once again join it with this straight line again, right? Again it's a straight line, and from this UDL, as you know, the UDL, it is a parabola. So here is the line which one is acting as a having a curvature, is a parabola. So you people know that it's a minus sign and it's a positive sign, and this is a bending moment diagram of a overhang beam. It is a very simple to draw, but here you have to focus. This is a 10 kilometer, it's a hogging moment, and here is a 20 kilometer, is a sagging moment, and here this is a line of reference. All right, this is a line of reference at which the line of reference at which you can see there is a one point, and this point is known as a you can say a point of contraflexure. It's a point of contraflexure. This point is known as a contraflexure. So at this point bending moment is zero. You can say bending moment is zero. Even you can also say in a proper definition, when bending moment changing its sign from positive to negative, or either negative to positive. When bending moment diagram change its sign from positive to negative and negative to positive, and then this point of intersection, all right, point of intersection of bending moment diagram to the reference line, it is known as a point of contraflexure, and you have to take into the account. And in examination, rather than the shear force diagram and bending moment diagram, examiner can also ask you about the distance of point of contraflexure from the left hand side, right? Distance of point of contraflexure from the left hand side. So you can find out the distance of point of contraflexure. So in between you have to find out this moment at some point at distance x, or whether you have to assume this and you have to take on the moment is equal to 0. So right now I am just giving this point of contraflexure as a name, uh, E, alright, it's a point E. So how can I find the distance of point of contraflexure from RHS or LHS, alright, as per the examiner request. So you can find it out this distance as per this diagram. So first of all, let me just remove this vertical reaction, as you are already aware about V is equal to 10 kilonewton and VB is equal to 20 kilonewton. So I can solve it out here. Point of contraflexure, right? So we know that moment at E. moment at E is equal to 0. That we know because it's a point of contrafactor, and the point of contrafactor bending moment changes sign from positive to negative, or either negative to positive, or in another case you can say bending moment at a point of contrafactor is equal to 0 always. So moment at E is equal to 0. Alright. So you can take a beam because you right now aware about this is your point A, this is your point D, this is your point B, and this is point C. So your point E, sorry, let me just renaming the proper location. Will never get it is a B, right? Exactly below side the B. This one is a B at which the 10 kilonewton into meter moment that you have calculated. So it is a point E, and you have to find out the distance. All right. So it is very simple to find out the moment at E is equal to 0. So you have to take the RHS or LHS. So right now it is easy to calculate the LHS. So it is a point B, and on the right hand side this is a load which have magnitude 5 kilonewton per meter and a span of 2 meter. And here I just assume that from point E to point B the distance is X. The distance is X. I'm going to find out this distance. Right. So can I take this moment is equal to 0? So the first moment at E point due to the support reaction, which one is a 20 kilonewton, it's a VB, and which one is applied in a anti-clockwise direction. So I can say it's a minus 20 into X. 0 is equal to minus 20 into x, and the second moment due to this UDL. So if you convert the UDL, so as I told you earlier, it's a 5 into 2, it's a 10, and it's applied at a 1 meter span. All right. So you can say just simplified form, it's just a 10 kilonewton, and it's from point, this is the point B. It's a 1 meter and it's a 1 meter, and you have to find out the moment from point E. So the total distance is x plus 1 meter. All right, from point E, and in the clockwise direction, so that's why you can say plus 10 into x plus 1. So this is your equation. 0 is equal to minus 20 into x plus 10 into x plus 1. So if you can solve this equation, then you can definitely have this value of moment. All right, so we can say it's a minus 20 into x. First of all, minus 20x plus 10x plus 10 is equal to 0, and minus 20x plus 10x, it's a 10x is equal to minus 10. You can say 10x is equal to you can say on the left hand side it's a minus 10x, okay, is equal to minus 10. So 10x is equal to 10. So you can say x is equal to 1 meter. So this is your distance. So this is the point of contrast factor. All right, it is very simple to calculate. So if anyone is asking you the distance of point of contact factor from point C, then your answer must be it's a 1 plus 2. So from point C, it's a 3 meter. From support B, it's a 1 meter, as you find it out. All right. And if someone is asking you about the point of contrast factor from the left hand side, then you can say it's a 4 meter. All right. So I hope you guys got it totally. So I'm going to start a new note.